queries you write with LINQ to entities use the familiar LINQ syntax. And they also use the object services infrastructure, and it's the object services that are responsible for translating LINQ to entities queries into something that the backend data stores can understand, also handling results that come back, and giving the ability to make modifications, particularly to track changes. And LINQ to entities will translate the results of any queries into an iQueryable collection of anonymous types. In the demo, we're going to write LINQ to entities queries against data that's stored in a SQL Server database. And so you're going to want to view the generated SQL statements. There are a couple ways you can do this. You can use the toTraceString method of the object query class. Now, object query represents a typed query against your entity data model, and the toTraceString method returns the command that's executed against the data source. So what you then do in code is cast your iQueryable result set to an object query, and you can then call the toTraceString method. And that will show you the SQL statement that LINQ to entities generated and sent to the SQL Server database to retrieve results. You can also use the SQL Server profiler. And again, in our case, since we're going up against a SQL Server database, we can use the SQL Server profiler. Now, if you're familiar with LINQ to SQL, you're going to be familiar with 90% of what you're going to see in this section, because the syntax you use to write a LINQ to entities query looks very much like the syntax you use to write a LINQ to SQL query. There are some differences, but for the most part, it's the same. So you can use LINQ to entities to write simple queries, retrieve one or more columns from a table. From identifies the table, where limits the results, select identifies the columns, order by you'd use to sort. So for example, here's a LINQ to entities query that returns company name, city, and region from the customers table for customers in the U.S. ordered by region and city. You can use scalar functions in your LINQ to entities queries, and a scalar function operates on a single value and returns a single value. So that's a good way to either filter or transform data. So here's a query that brings back products that begin with the letter A. You can use aggregate functions, and an aggregate function operates on a collection of values and returns a single value that summarizes that collection. So you'll typically use aggregate functions to return summary information: count, min, max, average, etc. So here's a query that just returns the number of orders placed. Basically says how many rows are in the orders table. So let's go see a demo of querying with LINQ to entities. I have the LINQ to entities demo sample application open, and this consists of an entity data model and then some code to query it. Let's take a look at the entity model first. The easiest way to look at this is in the model browser. If we look at the entity types, I basically have an entity for every table in the Northwind database: category, customer, employee, orders and order details, product region, shipper, supplier, and territory. So that's pretty much all the data in there. So I'll have a number of associations as well as a number of entity sets. And then in this application, we're going to query this data. So let's run this. Let's start out with simple queries. If you're familiar with LINQ to SQL, this is all going to be very, very familiar to you. So the first thing I'll do is create a new instance of Northwind entities, and that's going to represent my object context. And the object context manages the interactions between the data and the entity classes. And it also tracks changes. And when I want to reference entities, like customers, they appear as properties of the object context. So that's very similar to the way LINQ to SQL does it, where I would write from customer in nwin data context.customers. Here I'm going to query from customer in nwin entities.customers. So the first query retrieves customers in the U.S. From the customers, I'm going to bring back the company name, where the country equals USA. What I also want is to see the SQL statement that gets sent to the SQL Server. And I'm also going to look at these using the SQL Server profiler. So let me start that up. Okay. But more locally, I can do this because my query is an iQueryable collection. I'm going to cast that to object query and then call the toTraceString method. And that displays the SQL that's going to get sent to SQL Server. If I look in this in the SQL profile, of course I don't see anything yet because we haven't sent the query, we've just defined it. So now, when I want to evaluate results, for example, display a customer, now I can see that that statement was sent to SQL Server. Select company name from customers where country equals USA. And so I'll display the rest of them, and here are the customers in the US. In our next example, I want to bring back the company name, the city, and the region, and order these results by region and city for customers in the US. So again, define the query and display what the SQL statement is that will be sent, and then start executing this. And now I can go into the SQL profiler and see the same query here. And then for each customer, I can display the company name, the city, and the region. So here are the customers in the US ordered by region and city. In our next example, I want to get cities in Spain that have customers. So my query will say from cust in nwind entities.customers, where the country is Spain, select the city, but I wrap that in parentheses and use .distinct, and that's just going to bring back the list of cities. And so I'm going to select distinct city from customers where country equals Spain. When I do that, I get a list of cities in Spain that have customers. Let's look at using scalar functions. I want to get a list of products that start with A. So in my query, I'm going to say where product.productName.starts with A. So starts with is a method of the string class. Product name is a string, and I can use that in my query. So it's going to operate on a single value product name and return a value. So now when I run this, here are the products that start with A. Let's look at the SQL statement that's sent. And this uses cast and car index equal A. So that says anything where the first character is an A. Okay, in our next example, I want to bring back category names and also abbreviations. And the abbreviation for a category is the first three letters of the name in uppercase. So I'll query from category in nwindentities.categories, bring back the category name, call it name, and bring back category name.substring 0, 3 upper. So let's execute this query, and if we look in the SQL profiler, we see that upper and substring translate quite nicely into transact SQL. And we get a list of categories and their abbreviations. Our next scalar function is we want to find customers where the contact name is Carlos. So my where clause is customer.contactName.contains Carlos. Because I need to talk to a Carlos, and I don't know if it's Carlos or Juan Carlos. I just know that this guy's got Carlos in his name, so I'm going to bring back every contact that has Carlos in the name. And the SQL statement that gets sent, again, uses car index, Carlos, and if that is greater than 0, that means that there is a Carlos in there, and here are the Carloses. Let's look at aggregate functions. I want to do some summary queries. First thing I want to know is the total number of orders. So the query is from order in nwindentities.orders, select order, and then surround that in the parentheses and get the count. So now I want to know some information about product 7, including how many times it's been ordered, the total value of orders, the average value, and the maximum and minimum value of orders. These will all be separate queries, so the first query gets the count. Second query is going to go into order details, and where product ID is 7, it's going to sum unit price times quantity. It's going to multiply unit price times quantity and sum that up. The third query will get the average of that. Then I want the maximum and the minimum. So here's the first query that gets sent. For product ID is 7. Okay, so we've already run these. Yes, because aggregates don't have deferred execution. I keep forgetting this. Typically in LINQ there's deferred execution, but when you're returning just a single number, there is no deferred execution. So at the time you define the query, you're actually also running it. That's why all of these have been run already. So we can see that here we get the count. Here's unit price times quantity, another one to do unit price times quantity, and another one, and another one. So obviously what's happening is LINQ to entities is basically running this, is basically sending this query, and then it's figuring out the min, the max, the average, and the sum on the client. Interesting. So here's the information. So what you've seen here is some simple queries using LINQ to entities going up against our entity data model. The LINQ to entities query syntax supports querying from related entities using the join clause. So for example, let's say I want a query that brings back products in the beverages category. I could write a query that says from product in nwin_entities.products where product.category ID equals something. But what if I don't know the category ID for beverages? What I'd really like to write is a query that says where category name equals beverages. Well, I could do that by writing a query that joins the product entity to the category entity based on the category ID. But the entity data model already accounts for the relationships between entities, so I don't need to specify that in my join clause. I can just write my queries directly to take advantage of that. So here, my query is from product in nwin_entities.products where product.category.category name equals beverages. There's a one-to-many relationship between categories and products, so the product class, being the child class, has a category property that references its parent. In other words, it references the category that the product belongs to. So I can use product.category.category name to get the category that product's in. I can use lambda expressions in my LINQ to entities queries, and a lambda expression is used when I want to specify a parameter to a LINQ query method that is itself a function. So in this example, I want to get total revenue for beverages. So the top half of the query is what we just saw, product.category.category name equals beverages, and then I want to bring back the product name, and I want to bring back the number of times it's been ordered. There's a one-to-many relationship between products and order details, so the product class will have an order details property, which is a collection of instances of the order detail class, one instance for every time this product's been ordered. So I can count up the number of order details in that collection, and that will tell me the number of times the product's been ordered. And I can also sum the quantity times unit price. Now that is inside order details, so I'm going to call the sum method of order details, and I'm going to pass to it a lambda expression, identified as O, and then I'm going to instruct this function to multiply quantity times unit price. So let's go see some additional examples of querying related tables and using lambda expressions. Let's look at querying related tables. So that's example D. So I want to get a list of all of the products in the beverages category. So my query says from product in nwin_entities.products where product.category.category name equals beverages. There's a one-to-many relationship between categories and products. So the product class, being the child, will have a category property which represents that product's category. So this is actually an instance of the category class which has a category name property. So I can say where product.category.category name equals beverages and then bring back the product name and the unit price. And let's take a look at the SQL statement that's sent. And when that gets sent to SQL Server, that gets done on a join. The SQL Server has no idea that in my entity data model, products and categories are related, but it certainly knows how to do a join on those based on category ID. So the SQL statement that gets sent does an inner join. So I'm only going to see products that are in a category. And I guess that makes sense because products is the child table. You shouldn't be able to have a child with no parent, so there shouldn't be any products not in any category. So we're going to send an inner join, and then I'm going to be able to reference category name equals beverages. And this will return all of the products in the beverages category. So I don't have to write my link to entities query using the join syntax. I can just reference the object model. Okay, in our next example, I want to get a list of customers with 20 or more orders. So from customer in nwindentities.customers, where customer.orders.count is greater than or equal to 20. Customer, being the parent class or parent entity, has a property called orders, which contains a collection of orders for that customer. I'm going to get a count on that. If it's greater than 20, then I want to bring back the name of the customer. I want to bring back the company name and that number. So here's the SQL statement that will be sent. Let's do a count from orders where that count is greater than 20. And here are the customers who have placed 20 or more orders. Okay, next I want to get orders placed by customers in Washington State. So from customers in nwindentities.customers, where the region is Washington, bring me back the company name, the city, the region, and the actual orders. Okay, so let's look at the query that's sent. Because I asked for the orders, I'm going to get all of the information in the customer table and all of the information in the orders table for customers in Washington. So that should be a fair amount of information that comes back. And then as I loop through each of these, I can see the company name, the city, the region, and the number of orders. And then when I look at each order in there, I can display the order ID, the order date, and the shipped date. Now if we look at the profiler, we see again that there's one big SQL statement sent. There's no deferred loading going on here. We're not retrieving the customers and then retrieving the orders only when we want to display them. And the reason is because my original query said bring down the orders while you're at it. And here are the orders placed by every customer in Washington. Now, what if I don't want to do that? What if I don't want to bring down all of the customer information and all of the order information at the same time? So now what I'm going to do is rewrite this a little bit. First thing I'm going to do is just bring back the customers that are in Washington. So now what I've sent to SQL Server is a query that brings back the customer information where region is Washington. And then what I'm going to do is for each customer, I'm then going to load the orders for that customer by saying cust.orders.load. And now it gets sent to the SQL Server is this query. Bring back orders where customer ID is LazyK. So let's put a breakpoint right here. So let's run this. Now let's go, this displays, there's the lazy K. There are the orders for lazy K. Now let's get the orders for this customer. Trails Head Gourmet Provisioners, and then for the next customer, White Clover Markets. So in the first example, I brought down all of the customers and all of the orders at the same time. Now there's 3 customers and looks like about 20 orders. That's not a huge amount of information. So maybe that's the most efficient way to do it. Just make one round trip and bring back a moderate amount of data. But let's say there were 50 customers in Washington, each who placed 100 orders. Well, that's going to be an awful lot of information to bring down all at once. So maybe the better way to do it then would be to do it this way. Only bring down the orders for one customer at a time. Yes, that's a lot of round trips to the server, but you're bringing back a small amount of information each time. Okay, let's look at an additional way to do this. So here's another way of bringing back all of the information at once. I can use the include method of the customer's entity and specify that I want to include orders. So now I'm going to bring back customers and orders all at once. So if we look at the SQL statement, yet again, customers and orders all in one big query. And the results will look like this. So which should you use? The answer is whichever one makes the most sense. If it's a small amount of data, nothing wrong with bringing it all down at the same time. If it's a large amount of data, you may decide to break it up and do more queries that bring smaller amounts of information. Maybe you'll bring down customers and orders together, but then get the order details separately. Maybe you'll do a quick query ahead of time to find out how much information there is, and then you'll write your query differently depending on how much data comes back and forth. But we can certainly see using the SQL Server Profiler what query gets sent, and then we get an idea of how best to structure this. Okay, let's now look at lambda expressions. And a lambda expression is when you pass a function to a LINQ method that is itself a function. So here I want to get the total revenue for beverages. So my query is going to be from product in products where category name equals beverages, bring back the product name, bring back the count of the order details, bring back the number of orders, which is product.orderdetails.count. Product class has an order details property, which is the number of detail records for that product. In other words, the number of times it's been ordered. The product class has an order details property, which is a collection of order detail records with that product. So the count of that is the number of times this product's been ordered. And then I want to multiply the quantity times the unit price. So I pass this lambda expression to the sum method. I identify the lambda using O, and then I say quantity times unit price. And then for each product, I'm going to display the product name, the number of times it's been ordered, and the revenue. If we look in the profiler, we see again this query. Here's the product name. Here's the quantity times unit price. And notice that LINQ to SQL takes care of converting quantity to decimal so that it can be multiplied by the unit price. We don't have to do that in our code. Ordinarily, you couldn't multiply an integer by a decimal. You'd have to convert the integer to the decimal, but we don't have to do that in LINQ. That gets taken care of in the translation. And so here's the revenue, number of times each product's been ordered, and the revenue for each beverage. Another use of the lambda is basically as a where clause. So I want to return the total number of orders for product 7. So I could write this query to say, from detail in order details, where detail.productID equals 7, select detail, and then wrap that in the count. I can also pass this lambda expression to count as an argument. So count takes as an argument a filter, and that filter will be product ID equals 7. So here's the number of times product 7 was ordered. I can use a lambda expression when I know that my query is going to return one value. So I want to find order 10-5-30. So I could say from order in nwind entities.orders where order ID equals 10530, but I don't need an iQueryable collection returned from this query because I know there's one order with 10530, and so I know that there's only one result coming back. So what I can use is first, and then pass to first the filter. Now, if you're familiar with LINQ to SQL, you might use single here. You can use first or single in LINQ to SQL. LINQ to entities actually doesn't support single, so you have to use first. So when I run this, what does the profiler return? Order information where the order ID is equal to 10-5-30. And then I'll display the order date, required date, and the shipping date. What happens if I look for an order that doesn't exist? So here in this query, I'm going to look for order 530, which does not exist. That will throw an exception. So I need to wrap that in a try-catch so that I can catch the invalid operation exception and report back that there is no order 530. In LINQ, you can execute queries that group the elements of a query's results. And you'll often do this because you want to use an aggregate function to provide summary information for each group. So for example, total revenue by product or number of customers by city in Spain. So in this example, I'm going to group customers by city in Spain. So from customer in customers where country equals Spain, group customer by customer.city into a collection called grouped customers. And then when I want to return the city and the actual customers, I can use grouped customers.key. Because these are grouped by city, that's going to be the city. And then grouped customers will be the customers in each city. I mentioned earlier that you could use the join clause in your LINQ to entities queries to relate entities. And we also saw that you don't have to do that because the entity data model already accounts for relationships. But there may be times when you want to use the join. For example, you want more control over how entities are related. And there are two types of joins. There's an inner join, and in that query, it will not include parent items without related children, whereas the left outer join includes the parent items without related children. So if I wanted to see customers in Spain and their orders, if I did an inner join and joined customer to orders, I would not see customers that had no orders. If I wanted to see all customers regardless of whether or not they've placed orders, then I would do an outer join. So here's an example of an inner join. I want to see products in the beverages category. So I'm going to join the categories and the products on category.categoryID equals product.categoryID, and then I can reference the category name property in the category entity. So let's go see a demo of grouping and joining. Let's see an example of grouping. So that will be example F. So what I want to do is see customers in Spain by city. So my query will be from customer in customers where country equals Spain, and then I'm going to group customer by city into this collection called grouped customers, and then I'm going to return the city and the customers in that city. And I return city by getting the key property of the group, which is city. I know it's city because I've grouped by city. And then I'm also going to return the actual customers. So now, for each grouped city in Spain, I can see the city and the number of customers. So in Barcelona, there's one customer. What have we sent to the SQL Server so far? Here we are. The first thing we want is customers from a distinct set of cities where the country is Spain. So far, we've got customers. So we're bringing back the customers, and let's go back into here. And there's no actual group by clause in here, so the grouping is going to occur on the client. That's what I wanted to check. Okay, so now all of the information's down, and we're going to group locally. So we display Barcelona with one customer, Madrid with 3, and Sevilla with one customer. So our query brings back all of the information, and we can do the grouping locally. Okay, in our next example, I want to see categories that have more than 10 products, and I want to see the products in those categories. So from product in products, group each product by product.category.category name into grouped products, where the count in that group is greater than 10. Then bring back the category name and the products. So now for each category, again, we can say the name, the count, and then for each product in each category, we're going to display the product name. So in beverages, there are 12 products. In condiments, there are 12, and there are 13 confections and 12 products in seafood. Going to SQL Server. Again, this is handled all with one query. We're getting product information, grouping by categories where the count is greater than 10. So this is all done in one query. All of the information comes back at the same time. Now I want to get revenue by year. My query is going to go into order details, and we're going to group detail by the year. Now to get the year, we need to go up into the order. So detail.order.orderDate is the order date. That doesn't have a year property, but orderDate.value does. So we're going to group the details by detail.order.orderDate.value by year. Then we're going to order it by the year descending. And then I want the year and the revenue. So the year is groupedorders.key, and the revenue is the sum of unit price times quantity for each of the grouped orders. And so we can display here, by year, the revenue. Again, let's look in SQL Server. One query takes care of this. Date part year is where we get the date, quantity times unit price. All of this done in a single query. Okay, let's look at doing some joins. I want to see customers in Spain and how many orders they've placed. So the first syntax for doing a join looks like this. From cust in customers, where country is Spain, and join that to orders. So join ord in orders on cust equals ord.customer. So we know that the order class has a customer property which references the customer that placed the order. So I don't have to do this join based on cust.customerID equals ord.customerID. I can do it on cust equals ord.customer. I can actually do the join at the entity level. Then I'm going to group these orders by company name, and I'm going to return the company name and their orders. Okay, so let's see the SQL statement that's sent. Ooh, it's huge. Customers and orders. Bunch of joins in there. order by company name. So what do we see? We see 4 customers in Spain have placed orders. So even though I see a lot of outer joins in there, at the highest level where we join customers to orders, that's using an inner join. So we're only going to see customers who placed orders. Oops, where'd the data go? Here it is. So in the next example, I want to see customers in Spain regardless of how many orders they've placed. So in this join, I'm going to join ord in orders on cust equals customer into grouped orders. Bring back the company name and the orders. So now when I do this, I see there are 5 customers, and I get this customer who has placed no orders. So this is a left outer join. So we go up to here. Now we're joining customers to orders using a left outer join. So what's the difference between these 2 queries? Here was the grouping where I grouped by company name. And here I just joined into grouped orders. So it was actually this group here that caused this to be an inner join, and leaving it out, down here I wind up with an outer join. The inner join does not return parents with no children. The outer join does. So again, this is a good reason to either use the SQL profiler or at least display the SQL statement that's generated so that you can understand what your queries are doing. So you have control over whether you do an inner join or an outer join.